Hi guys, welcome to our mini lesson on adding and subtracting radical expressions. So when we're looking at adding and subtracting radical expressions, we need to look at both the coefficient of each radical and the radical themselves. When you're thinking about adding and subtracting a radical expression, you're going to be treating the radicals as variables. So when you see 5 root 3 plus 17 root 3, I want you to also think about it as 5x plus 17x. 5x plus 17x. What do you guys think that is? 22x. So if I add them together, it's going to be 22x. When I'm adding radical expressions, it works exactly the same way. So if I have 5 root 3 plus 17 root 3, when I combine these two together, I'm going to receive 22 root 3. as our final answer. I do not want you to put this into your calculator and round because that will not give you an exact answer. In mathematics, you always want an exact answer, and rounding this decimal will not give you that. The only time you round a decimal is if a problem tells you, or if you have a word problem where you need to round. This is not a word problem. Okay. Let's take a look at the next example. I have b root a minus 5b root a. Well, let's see if they have the same radical. Because if they don't have the same radical, then they're not like terms. I see they both have the square root of a. That tells me they're right terms, like terms. So now I have b minus 5b, which tells me, okay, well this is going to be negative 4b root a. Because 1 minus 5 is equal to negative 4. Just like 1x minus 5x will equal negative 4x. We're just subtracting like terms. Now we're going to move on and take a look at the last example here. I have the square root of 20b to the 5th minus 45b to the 7th. So sometimes you need to simplify the radical first. So when I take a look at the square root of 20b to the 5th, I'm going to start a little over here actually for some room. So if I have root 20 b to the 5th, I know when I start breaking this down, this can become square root of 4, square root of 5, and I can also make this b to the 4th and b, because I can break up b to the 5th and b to the 4th and b. I know the square root of 4 is 2. I know the square root of b to the 4th is b squared, and I'm left with 5b inside the radical. So when I simplify 20b to the 5th, this will be 2b squared times the square root of 5b. Next, I'm going to do the same thing with the 45b to the 7th. So 45b to the 7th, I'm going to have the square root of 9, the square root of 5, and I'm also going to have the square root of b to the 6th and the square root of b. If you have an odd power, just subtract 1. So I know that 6 plus 1 will give me 7, because any even exponent is going to be a perfect square. Now, I know the square root of 9 is 3. I know the square root of b to the 6th is going to be b to the 3rd. B to the 3rd. I know the square root of 5, well that's not a perfect square, and can't be simplified any further. And then same with the square root of b. So now I have 2b squared times the square root of 5b, subtract 3b to the 3rd times the square root of 5b. So now when I'm trying to subtract, I need to make sure that I have like terms. I'm going to have 2b squared times root 5b minus 3b to the 3rd times the square root of 5b. I may have the same like radicals, but I also need to look at the coefficients. I see that the coefficients are not like terms either, because I have b to the 2nd and b to the 3rd. So you cannot subtract, because they are not like terms. Sometimes this will happen. Sometimes when you simplify first, you will get like terms. Sometimes you will not. So step 1, simplify. Step 2, when you have the like terms, add or subtract the coefficients, and that gives you your final answer. Please complete your check for understanding and work on your practice for this station. When the timer goes off, you will move to the next station. If you are unable to get the check for understanding correct, speak with us here at your table and they will assist you.